UDC.
Welcome everyone, and thanks for joining our presentation between PG&E and UDC. My name is Tom Finkhousen. I'm a project manager with UDC. I work out of our Tampa, Florida office. These are a few things that we'll be talking about. We'll do a brief introduction, overview, project approach. We'll talk about the benefits of the project and provide some contact information. With me today to go into further detail about the project is Tice, Project Production Manager, UDC, and Alec McCullick, Business Systems Specialist with PG&E. I now hand it over to Alec.
Thank you, Tom. My name is Alec McCullick. I work for PG&E as a Business Systems Specialist, working mostly within the GIS organization under the gas side. PG&E is a company that is located in Northern California. I'm sure most of you have heard of them at some point. And we serve basically from the Pacific Ocean all the way out to Nevada, and then from Bakersfield all the way north to Eureka, covering most of the state's geographical region. Today we're covering the ARMS project. So we're going to kind of touch on how this helped PG&E through some of the challenges that we were experiencing around connecting meter data to our services, and also kind of cover our process and how we completed the categorization of the data sets themselves. The challenge for PG&E around the ARMS project was to accurately represent our gas meter data. Previously, our gas meter data and our service data hadn't been co-located. They weren't in the same database. Our customer information lived with our customer care and billing data sets, and our service data lived with the rest of our asset data, underground distribution and also the service information. One of the things that PG&E was looking for from this project was a way to visualize the meter data alongside the asset data. It's a real challenge to go and maintain meters all across California, especially when you have difficulty figuring out which service belongs to which meter. This project would establish a process for us to be able to maintain that data set long term, linking records over time and putting us in a position where we weren't going to get back to where we were before, where we didn't have meter to asset knowledge. The goal of the project was to increase accuracy of our locational information, but also increase the accuracy of our data within the meters and the assets. When you link data sets like these together, you sometimes come across opportunities as you're going along where we can improve upon internal data sets. In our case, we came across elevation data for our customer care and billing department, also EFE maintenance information improvements that we could do, where we didn't have to do as many truck rolls because we knew how many meters were connected to that service. Reducing the amount of truck rolls that we have made us more cost effective. It also allowed us to meet the schedule for the project. Other departments came in and helped us with the locational information. Electric was already doing a project around the common link between services and meters because of the PSPS, the power safety shutoff program that we're doing here in California due to the wildfires. That information helped us be able to accomplish our goal. The primary goal of our project was to create that common link that I've been talking about between the services and between the meter data. So I want to go over some terms and definitions to kind of help us understand what we're talking about. When I talk about a service, I'm talking about the connection point from the distribution main in the street to the customer house. So at PG&E, we call that endpoint, kind of, you see the black dot in the bottom image, that represents the riser and the meter set. The line between the tap off point and that black dot ends up becoming and being defined as the service. That service location represents the riser and also the meter. When we talk about a meter, we're talking about the combination of customer data and also field information about which meter is attached to that customer, which service level agreement they have it attached to their bill, that sort of thing. When we talk about a premise is the lot that the service is established within. So where you have a meter, you could have multiple meters, even a meter manifold where you have it attached a group of meters. The project itself is named ARMS, and it's a name that we came up with locally, of course, and it stands for the Accurate Reconciliation of Meters and Services. It represents the logo that you see above it. The logo is that service location at the end of the service with each different kind of categorized meter coming off the end of it. Erica is going to touch a little bit more on that later in the deck. The last thing I want to touch on before I hand it over to Erica is the schedule. Our schedule, or our project timeline rather, began in 2018 with the initiation of the project. Our distribution integrity management program, our risk assessment group, came up with a script that would join the two data sets together so we could take a look at where our most critical customers were and how they were being impacted by our risk activities. We took that script and turned it into a categorization model. We categorized the locations that we thought were accurately matched and then started to reduce and work our way through the remainder of the matches. We knew that there was a subset of the data set that needed to be manually checked, and that's when we launched in 2020 the beginning of our ARMS project. And that ARMS project was to manually review what couldn't already be automatically connected through the script. In 2021, we worked through our meter review. I think one of the ways that we were successful is we started doing daily huddles back at the beginning of 2020, and the transition during COVID was handled very well by the rest of the team by already having digital huddle boards and also daily touch points that were all done through Teams. Stepping into 2022, something that's not even on our slide deck yet is we've been approved for an IT project to move this forward. This ARMS project covers the data side, but there is an accompanying IT project that will follow along and make sure that this data is maintained going forward. And that starts in Q4 of 2021 and goes into 2022. And now I'm going to hand it off to Erica to talk about that data.
Thanks, Alec. My name is Erica, and I will be doing the project approach. So PG&E has 4.6 plus million meters. They also have over 3.5 million service locations. And in order to properly review this data, scripts were developed to programmatically place the meters onto service locations. These scripts also split the meters up into 5 different confidence categories based on how confident we are in this type of placement that was made. So these are the 5 confidence categories that we created to evaluate the data. High confidence is what we would consider our goal category. Meters that fall within this confidence category are the most confidently placed. We then go down to our medium and low confidence categories, where we are less confident in the meter matches because parts of the addresses were removed in order to make a placement, such as apartment numbers, directionals, or the street suffix. Meters in our medium confidence category also have a unique address, whereas meters in our low confidence category could have matched to multiple address locations. Then we have our no confidence category, which contains meters that did not spatially match with a service location and they require manual verification. And our final confidence category is corrective action. All meters that are in this confidence category have been manually reviewed, but they could not be matched to a service location. Many of these need to have a service drawn in order for the placement to be spatially correct. So here we have kind of an overview of what we started out with at the very beginning. So we had about 62% of all of the meters already being in high confidence. Then we had 8% of the meters being in medium, 1% being in low. Then we had a decent chunk in no confidence. We had 29%, and we started out with 0 meters in corrective action because those are manually verified. So initially there were none. So within each confidence category, there are subcategories, which are based on the following meter match methods. The first 4 match methods that we have up at the top are address type matches, And the final ones at the bottom are based on geographic matches. So if we're taking a look at the fifth line, these meters are placed by latitude longitude attribution and matched to a service location that shares a matching address number in the same parcel. The sixth one, meters are placed by the premises latitude and longitude attribution and matched to service location, matching that address number and sharing the same parcel. And then our seventh one is where meters are spatially matched to a geocoded location and matched to a service location that is existing in the same parcel. And then lastly, we have our manual match. So with our manual review process, when we started out, we did have 1.5 million meters to review manually. In order to do this, the team uses a couple of different methods. Along with the GIS information, we are also utilizing Google Maps and Bing Street View. We will also go into different assessor websites to use parcel information so that we can make better matches just based on parcel data. Usually you can get like apartment numbers and stuff like that a lot easier. So we have our data acceptance testing team who will go through these deliveries. We also have an audit team that will review those batches after the data acceptance testing. And then our audit team will provide a quality report and deliver it to PG&E, who will then approve or reject the batch. We started this project back in June of last year. Since then, we have completed 9 divisions and we have 5 that are currently in progress. And we are anticipating an end date of August of this year. And I'll let Alec talk about some of the benefits for PG&E on this project.
Thank you, Erica. What you see on screen is a message from our leadership. This message kind of encapsulates how I feel about the project and the benefits that PG&E will receive as this project is completed and in the years to come around our response in emergency, our response during maintenance, and also our understanding of our assets. One of the things that I personally find valuable about this project is the emergency response, the ability to respond to customer requests, and also to be able to reach out to the customers that are affected. During one of the incidents in Sonoma, where we had a wildfire that impacted customers inside of our cities, we struggled to figure out the amount of customers that were impacted. And I think with a project like this, I'd be able to tell that information in a matter of minutes. Outage management is always a difficult process, but I think having assets tied together like we're working on through this project and projects like this make PG&E a safer utility within California and also make California a safer place to live. I'm going to hand it over to Tom to close us out.
Thank you, Alec and Erica, for explaining the ARMS project. And I'd like to also thank the entire ARMS team for making this a successful project. We provided additional contact information if anyone would like to reach out for further information related to the project. Thank you.
UDC.